Hello everyone, it's Cyanel, and today we will see how work and how to build this memory device that I use in my computer. This design is not exactly the same that I use in my computer, because in my computer I save one tick from here, but the wiring is a bit more complex. So for explanations I will use this design, but it's exactly the same for the biggest part. Okay, let's do this. This is a queue memory or a first in first out memory. So you can write on one side and read on the other side. The value that you write will go through all memories until a memory is already used, and so the value is saved just before. So let's take a quick example. We will write 3. So now the 3 will go through all memories and is saved in the last one. Now if we input 5, this value goes through all memories, but the last one is already used, so the 5 will be saved here. And let's input a last number, let's say 7, and the 7 is now in the third memory here. So you have 3, 5, 7. Now with this value we can do different operations. So on the writing part you can write a value that what we've done before. You can also reset all the memory. You can loop the value, that means take the last value and input it at the beginning. You can, on the reading part, you can count for the number of value that is in the memory. You can read the last memory at the end. You can read and erase the memory at the end, and read and loop the last value. So if we read only the value, we will see the 3 because it's the oldest value that we input. The 3 is on these 2 bits. The white is for value. The all other lines are for extra data. Then if we read and erased, we will see the 3 again, but now the 3 is erased, so we have only 5 and 7. Now let's take another example. Here we will read and loop, so we have 5 in the last memory. We will read 5 here, but the value is looped once, so now we have the 7 and the 5 is here because we read it and input it at the beginning, so go through all memories and saved here. So that is what this device can do. Let's see now how you can build it. Let's start the building with this really simple memory cell design. So here we have a memory cell, and we will use it by default on this state. The input is here, and here will be the reset line. So let's build the input. So we want to input this redstone dust from this torch, and we will have redstone dust here, and the outputs will be here. Now we also want to lock the inputs as needed. So here is a torch to lock the input. Let's reset this. And the last thing is this reset line. So with this repeater we can reset the memory to power this line here. Now we have one cell, 1 byte. So we need to stack this 8 times in this direction to store one entire byte, and every 2 blocks, and 7 times, so 6 more times in this direction to store 6 more bytes. And in this direction it's every 4 blocks. So let's do this. Let's build some extra blocks to make this thing stackable. So here, 1 block here. We need also a torch here for the input of the next cell, and the reset line, the lock input of the next cell. I think that's all. So now we want to stack this. So now in this direction we have 1 byte. Maybe I need to replace, oh no, it's okay, it's already linked. I think we are good for this. No, now we don't need these things. Also here this repeater is useless because this one already lock this line. And now we want, yeah, here this torch is too far from the end, so we need to do this a little bit different, like this. Don't need this one, and that's all, I think. So now let's stack this again. So this is all memory cells individually and stacked by bytes. Now let's do the wiring to allow these things to become a first in first out memory. To remember, this cell here is saying if we have a value in this byte. So we grab this information from here, and so this torch is on when we have an information in this byte here. So what we can do is lock the input of this byte when we have an information, because we don't want to write on a value that is already stored in this memory. So we can grab this thing, placing a torch here to lock or not all this line. As you can see here, we have a power of 1, so it's rich. Now we can connect this with the torch here. So by default these torches are off, so the input can be read by the memory. But if we have a value here, then the torch turn off, the torch here turn on, and the signal here can't pass through this torch because this torch is locked. So that way we have the lock for the current cell of memory. So let's build this for the others. Now we want to lock the writing of memory. So from this torch here we can lock on these repeaters and lock these lines of redstones. So now in this byte the signal can go through these torches, but it can't be saved in the memory. By default, it's really important that the signal can go through but can't be saved. But when we have a value in this cell here, that means that now we want to store the value in this one, so we need to allow the write part. So when this torch is on, when we have something here, we can grab the signal and turn off this torch, and that way when we have a value here, this torch turn off, and now the all these cells are unlocked, and so we can put and save a value in it. So let's do this for the other cells. So now we have complete the FIFO first in first out memory. So let's try here. So here are the inputs, and here is the bit for is a value in the byte. So let's first in a value. So you have the value stored here, and then another one, and as you can see, the value is stored here. And if we reset this line, so this value, it will erase, and the next one will go on this one, because when we erase this, so it allows the writing part, and the input is directly connected to the memory, so this value will go through and go to this cell, and when this cell is filled up, the reset line will reset this value here. So that's the work of this memory. Now we will see some wired for comment all these things with operations. Now let's build the input. So we need to up one block, then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and one more. So we will have a torch here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15. Okay, we are good, 15. So here is the bus. Let's copy this. So now we have all these inputs. So we want to separate values and the extra bit here. So we need to lock values with a torch here, sorry, not here. So now we can place all these torches for inputs for the value, and here we have the inputs of the operation write in. So when we write a value, we allow the value to pass through these torches, and we need a repeater on 2 tick here to also save that the value is input. So that way, if it's a 0, we have the information anyway. Let's reset this because I've failed a bit. Okay. So now we have the first operation, that is write in. Really simple. You can also build connected to that a little memories. In my bus here, it's all delayed correctly, so that way we don't need any memory for the input, but maybe you can build it with memory before and release the value when we are ready to save it in the register. So that is as you want. now we build the output. So you can break all of these things here. We don't need it. This one also, yeah. So here we can break all of these blocks. So we are reading the last cell. So the cell is here. So we can read the value from this torch. We have a repeater below on top, so it's not an issue. And grab the signal here. And we want to go with the signal at the beginning of this memory. Maybe in your design of computer you can have an input on one side and the output on the other side. It's possible, and it's faster, I think, because you read this side, so you have no delay here. If you loop that way, you have a delay between the reading and the value arrived here. So it's better to build the output this way. But if you do, this thing can be useful for the loop function also. So you can build it anyway. So let's place all these torches. Now we want to allow or not the output, so we can do it with locking the output with this torch, because by default it's on, but when we have a value it's off. So now with this torch we lock the output. Let's build this for all bits. So you need only one of two, but I think the look is better when we have a torch each block. We lose a bit of performance, but I prefer the style, so yeah, I do it. And now we are here every 2 blocks, and now we can connect all of this. Also, you need to have the inputs of this line here. You don't have the choice because here we have 1, so you can't output here. So let's make the torch here. So as you can see here, this torch is connected to this output, so it can be dangerous, but in fact it no matter, because when this line is off and so this line is on, that means that you have 0 in the memory cell. So in fact this torch is always at the same state as this repeater, just 1 tick before. So it's not really an issue to place this torch here. Okay, so now we can comment the output. Let's build the bus to the beginning. Okay, let's continue with the command of this thing. In fact, it's not here, it's not here, it's here. Oh. That way we can connect this with this torch, and also this torch with the reset here. So now we have 2 different inputs here for to control the output. Here is the allow output, sorry. So when it's locked on, or when you have no value in the memory, you can't output. But when you have a value, oh, this needs to be on. When you have a value here and you unlock, the value is output on the bus below. And when you allow here, when you have a value in this memory and you want to reset it, you flick this lever and the value is reset. So here are these inputs. For the bus below, I've built it this way, so the repeater is not as full at the full length, I think, because here we have 6 plus 2, that is 4, so you can place it later, but anyway. Now we want to connect this for the looping part and the output part. So let's build the output and the loop part. Now we can separate this signal into 2 different outputs. So you have here the output to the main bus. Here you can extend this line. You can command this line from this dust here on this line. I think it's better to do it on this color. And here is the output for loop the value. So in order to loop the value, we need memory here, because when you read the value, you read it really fast. It's here a little memory, so it's only 1 tick. But before input the value, you need to wait for all the memory cells to ripple to the next one. So it takes a bit of delay. So you need a buffer here to wait for this. So let's build the connection here. So you have your cell and the connection with the bus. Now we need to build here the reset for the memory, and here is the lock for the memory. Now we can build it this way. So you have here something like this. You can save a value here, and then when you want it, you can input it on this line, and with this thing it will become a 2-tick signal. So now it's on this memory here. Let's reset. So let's build this for all the 8 bits. You wanna need to do this. Oh. Yes, and now stack this thing with also this. Okay. Now let's stack this. So it's from here. Let's build it here. Okay, now we don't need that. Let's connect all this bus. So here, and also this. It's a bit annoying to build this. Okay, with this. Okay, I can from here. Okay, now let's modify a bit. So here we need the signal because of the length of the signal. So let's do this. Also here, it's a bit difficult. I think it's something like this, and so here we don't need this, and that way we can input I think it this way. Let's try. We have one, yeah. So here it's good, and now we need the input to be here. We can break this because we don't need any output for this bit. We want it for the loop, but we don't need to output it. You can, but here I think it's not useful, so I erased it. Let's put a torch here to power all of these. Oh, it's 2, so we don't need that thing at the end, but anyway. Here we need a bit of delay, so let's build some repeaters for the delay. And here will be the commands, so we will see it later. Now we have the wiring for these two commands, these two outputs. Now we need to connect this line to allow the write on the bus here to input. So let's build this. A torch here to write on the bus only if you have a value here, and go up 3 more blocks. After we will have a block here, so let's do this, and a torch here. That way, the if this cell is containing something, then the torch here, sorry, will turn on and lock this memory to release. So we can release and input the value only if this cell is empty. It's really important to do this. So now we have the link to the loop, and maybe we need to connect this wire to the loop function, but I don't remember how I've done it. So it's, oh yeah, because of the, yeah, okay. So it's 2 tick and 2 tick again. Let's do this. So you have here a torch to reach the end here, a dal slab here for the torch, and then you have 2 tick here, a block with a redstone here, and again 2 tick, and then here you will have the loop command. So that's the wiring for the loop command. Now let's wire the count command. So here, if you remember, this repeater say when it is off that a value is in this byte. So we can grab the signal from here, and then other side, put the signal on this line here. That way we can select this here, do the same thing, and now we can code here the binary code of the memory cell. So no, it's here, here, and here. Let's do this. So here you have the number coded on 3 bits. So you have the 1, because if you have something here, you have 1. If you have something here, you have 2 cells, and so on. 3, 4, 5, so on, so on. But we need to select only once line each time. So if we have something in this cell, we need to lock the previous one. So we can do this by adding some wire here and a torch here. And that way, oh, no, not here, we can select only once each time. So I will build the thing for the rest of bytes. Now let's code this. So you have now 3 here, then 4, 5. Under the 5 you need some repeaters, and then you have 6 and 7. The 7 need to be this side. Okay, so here I've take this and repeat, so it's the same thing but with this blue part. And now we have outputs here, and we need to output this, so you can output separate, but I decide to connect it with the bus here. So let's do this. So you have here you need a slab here, then here no, here it's a repeater, so it's okay, and you can wire up all these things. And the last one, so here you can do different way, but I like this one. Okay, so now we have the connection, and we need to control this. So what we can do is something like this. Lock this wire and lock these 2 wires, and we can comment from here to ticks, and here is to ticks also. I prefer the blue one here. So that's it for the count command. Now we want to connect these 2 inputs. So let's do this here on the same block and go here. For this one, same things, and 2 down. Now when we are over this block, put a torch here to connect to this line, and this one, oops, will be here. Now we need to do a bit of logic. So here is one line, here is the other line, and go up here. So to remember, this line allow the reading, and this line resets the memory. What we've done here is we transform that 2 signal into one to read only, and one to read and erase the memory. So that way we have these 2 things, and now we can extend this. I need to check the length. So it's here, and I think we need to do this, if I remember good. So here you have the same, and 2 slabs, something like this. and a block here. So now we can comment with these two lines the reading only or reading and erased. So let's do the last part that is not really interesting in block by block, but it's most for understand the logic of wiring and what we need to connect to what. So also delays that I build here is optimized for my main bus, and it can be different if value arrived at a different moment. So yeah, it's for the logic of what you need to connect to what. So first you have here the count function. So if you need to count, you only need to release the data from this bus onto this one, and so you need to unlock these lines. Really simple for this one. Then you have the read function. So to read, you need to allow the read here. So it's this line. So you need to do something like this, and then go down. So we need here a slab. No, only 2 ticks. And then wire all these things. I've made a mistake with this line. It's one block at the right here, not on this block, but on this one. And here you can connect all those things. I think it's good. So are we? Oh, we have one of difference. Let me check. Yeah, the repeaters are here. So now we are good. And so now we connect this to allow the reading here, and you need to allow the reading here. So you have a repeater also here, and 2 blocks. That way we release at the right moments the line here to release the value on the main bus. Then you have these two, that is for read and erased and read and loop. The interesting part is that read and erased is exactly the same as read and loop, but instead of activate the looping part, you activate the release part here on the main bus. So what we can do is connect these two here with this repeater, and then this repeater is connected to the read and erased part at the back here. So we can connect it, because these two functions need to read and erased. Okay, I think we can do something like this. And now only the read and loop, so this, let's say this one, needs to loop. So we need to connect it to this wire, and okay, I've done it this way. Not really important, but I like consistency, so if I can make the same with all, it's good. So here we have hits, and now we need this function that is the loop function. So here you only need to loop, so I've connected it here, but also you need to release the no, it's only loop. So I think it's all, and yeah, it's reset function that I forgot. So for the reset function, you can grab from here, the reset is simple. It's based on these torches. So you need only to force this wire to be on. So you can build it this way. You need to input on this wire and not this one to reach the end. It's important. So you do like this, to block. Okay, and the last one. Now you have all these and wire here. I don't remember where I put the repeater. So it's here on this one. And now I think I just take the maximum length. So let's do this. We have one, perfect, and we can do it like this and connect it. Maybe something like this. I prefer to do that. Okay, and repeat torch here to lock all. I've forgot one thing. That is, when you loop only, it's writing only commands, but you need to release this data. So here you need to connect the reading command to the loop command, sorry, with this repeater onto this line here. So that way you have your device operational. So you can build your inputs like this, for example, and command these inputs with the torch or other things. And yeah, it's done now. So now we have our FIFO memory, first in, first out, or queue memory. Remember that you can also put the output on the other side. It depends on what you want to do with this. And here is only an example of wiring, and it's a wiring optimized for one connection. So if you want to do another wiring, you can. If you want to add some more operation, you can. If you want to remove some operation, you can, and modify a bit. So the most important part to respect is the cells and all the gray part, but the color part are function, and so you can change it a little bit. So that's it for this video. I hope you learned something, and see you soon. Bye.